Hello, I'm Bertrand, co-founder of Pruna, and today I will present you an overview on how to compress AI models. First, how does AI or deep learning model work? All AI models usually work in a similar way. They process some input data from different types of modalities, and then they run some instructions. It can be linear transformations like big matrix multiplication, or nonlinear transformations. And they repeat these blocks again and again until getting the final output predictions. These instructions usually use energy and run on some specific hardware and using some specific programming language. The instructions that require the most energy are usually matrix multiplications. To make these instructions running more efficiently, there are many compression methods. Here you can see 6 of them, and the idea is that you should not use a single one, but combine them together to get the best efficiency gains. Let's dive a bit deeper into 3 of them. The first one is pruning. Pruning usually works in 3 steps. You first take the weight matrices of your models and give a scores to every single value. Then you rank the values with respect to the scores you assigned. And finally, you remove the least important scores, thus getting smaller matrices which can be run more efficiently. There are many variations for the pruning. For example, you can prune different structures, single values, rows, channels. You can use different scoring functions, random, magnitude, or gradient-based scoring functions. You can prune at different sparsity, 50%, 60%, and you can prune at different times, before, after, or during training. The second type of method is quantization. The idea is weight matrices are usually encoded in 16 and 32 bits, but can be reduced and can be encoded in a way less bits, like 4, 2, or 2 bits. A simple way to do this is linear quantization, where you rescale every value into a range that can be encoded in this lower number of bits. There are many variations of these quantization methods. For example, you can quantize different structures, tensors, channels, or groups. You can also use different methods like linear quantizations or codebook quantization. You can quantize to different number of bits, even go to 1 bit. And you can also quantize at different times during or after training. A third method is distillation. The key idea of distillation is usually people have large models which can be used as teacher models, and you can distill the information into a smaller model like student model. The standard way to do this is called response distillation, where you mostly actually generate synthetic data based on the teacher model and use this data to train the student model. But you have also many variations, for example, feature or weight distillation. There are variations also on how to choose the student. For example, you can use different architecture or size or precisions. And you can also distill in different ways, either train both the teacher and student model together or train the student model subsequently. After you looked at all the compression methods, you can actually look at the generation of your AI models. Here, for example, these are 2 images generating, one with the base model, one with the compressed model. As you can see, there are almost no difference between the 2 images, but the image on the right has been actually generated way more efficiently and using way less compute. Thanks a lot for following this quick overview on how to compress AI models, and hope it can help you to compress your next model.